Imagine a farmer standing in a parched field in rural Rajasthan during the summer of 1947. The ground is cracked into deep fissures that resemble a broken mosaic. He watches the horizon for a cloud that never arrives. His family has used the last of the water from a well that took generations to dig. Now, that well is a dry stone throat. This is not a sudden disaster but a quiet and heavy struggle that has repeated for centuries. Without water, there is no food. Without food, there is no village. This man represents millions across the Indian subcontinent at the dawn of independence, trapped in a cycle of violent monsoon rains followed by months of bone-dry heat. The rain would rush in, strip the topsoil, and flow uselessly into the sea, leaving the land thirsty again within weeks. Modern India had to solve this fundamental problem of survival, how to catch the rain where it fell, instead of letting it escape to the ocean. This video explores the technical and social history of how India transformed from a water-scarce region into a leader in decentralized water conservation, shifting from massive industrial dams to the revival of ancient, local engineering techniques. When India gained independence in 1947, the government focused on large-scale infrastructure. Massive gravity dams and thousands of miles of concrete canals were seen as the path to modernization. The Bhakra-Nangal Dam, completed in 1963, rose 226 meters high and helped power the Green Revolution in the northern plains. These temples of modern India delivered irrigation and hydroelectric power, but they were expensive, took decades to build, and often failed to reach remote hilly villages or the deep interior. By the 1970s, many rural areas saw falling water tables due to heavy reliance on electric pumps drawing from deep underground. The real breakthrough came from the ground up. In the 1980s, a movement revived the Johad, a simple crescent-shaped earthen pit designed to capture monsoon runoff. The principle is elegant: slow the water, spread it, and let it sink. In Alwar district, Rajasthan, the NGO Tarun Bharat Sangh worked with villagers using local labor and materials. By the mid-1990s, thousands of Johads had raised groundwater levels by several meters. Streams that had been dry for decades began flowing year-round. This success popularized the slow it, spread it, sink it philosophy across India. One of the most effective techniques is the contour trench. Long, narrow ditches, about 0.5 meters wide and deep, dug along the natural curves of hills. They break the speed of runoff, prevent erosion, and force water into the soil where plant roots can reach it. Between 1990 and 2005, millions of these trenches were dug manually across Maharashtra, Madhya Pradesh, and other states. Another key structure is the check dam. Unlike giant hydroelectric dams, these are small, often under 2 meters high, built across streams or gullies using stone, masonry, or gabions. In Gujarat, tens of thousands were constructed in the early 2000s. They slow water velocity, allow silt to settle, and promote percolation. In Saurashtra, farmers tackled non-porous basalt rock by creating recharge wells. They diverted rooftop and field rainwater through simple sand-charcoal pebble filters directly into existing wells, turning every farm into a mini recharge system. By 2015, the government scaled these approaches nationally through the Pradhan Mantri Krishi Sinchayi Yojana, PMKSY, emphasizing per drop, more crop, and decentralized harvesting. Satellite imagery and GIS mapping helped target optimal locations across hundreds of thousands of villages. The movement reached new heights with the Paani Foundation in Maharashtra. Starting in 2016 with the Satyamev Jayate Water Cup, villages competed to harvest the most water through shramdan. In just a few years, thousands of villages moved tens of millions of cubic meters of earth, building continuous contour trenches that transformed entire districts. This was the necessary deed to reverse decades of destruction from over-extraction via tube wells, which had dropped water tables dramatically in some areas. Today, in 2024-2026, we are seeing the return phase, restored hydrological cycles. Soil acts like a giant sponge, supporting native vegetation that further stabilizes the land and increases humidity. In adopting villages, farmers now grow 2 to 3 crops per year. Incomes have risen, and expensive water tankers are no longer needed during dry seasons. The success is measurable. Groundwater levels have stabilized in many regions for the first time in decades. The total storage from millions of small structures rivals that of several large dams, with far greater resilience. If one check dam fails, the impact is local. A big dam failure would be catastrophic. In sandy desert areas, India has pioneered plastic-lined ponds using HDPE film, often 300–500 microns thick, to prevent seepage into saline layers below, allowing fresh water storage for months. In conclusion, India's water journey since 1947 has moved from the monumental, steel and concrete, to the molecular and local. Simple ditches, Johads and contour trenches prove that the most sophisticated engineering sometimes means working with the land's natural slope and letting gravity do the work. While climate change and shifting monsoons remain challenges, this decentralized infrastructure provides a powerful buffer. The quiet struggle of the 1947 farmer has been answered by a massive collective effort of earth-moving, community wisdom and technical innovation, securing India's future one drop, one trench, and one village at a time.